Now we're going to talk about solving simultaneous linear equations by using the elimination method. Unlike running into rocks, using the elimination method is not as painful as it sounds. There are certain times when you're going to want to use the elimination method as opposed to the substitution method. For example, if we take a look at the following set of simultaneous equations, we have 5x plus 2y equals 18. And 6x minus 2y equals 26. Now in this case, what I can do using the elimination method, the idea is to add the two equations together so that one of your variables temporarily cancels out. Now this is the important thing to remember. It's a temporary cancellation. So taking a look at these two linear equations, what I'm going to do is add them together so I get 5x plus 6x, which is 11x. And then positive 2y plus a negative 2y cancel out, leaving me with 18 plus 26, which we all know is 44. So then I get that x equals 4. But if you remember, every simultaneous linear equation solution must contain an x-coordinate and a y-coordinate. So in this case, once I find that x equals 4, I'm going to take that x and I'm going to plug it back into one of my equations to solve for y. Just like before when you were solving for substitution, you need to find one coordinate, then plug it back into the original equation, one of the original equations, to solve for the other coordinate. So let's go ahead and take the first one, and I'm going to take 5x plus 2y equals 18. But instead of x, I'm going to be using 4, so 5 times 4 plus 2y equals 18, which means 20 plus 2y equals 18. And if I subtract 20 from both, I get 2y equals negative 2. So y equals negative 1. So far, I think that my solution is going to be 4 comma negative 1. But before I can be sure, what I really want to do is test those values out. So 5 times 4 plus 2 times negative 1 equals 18. Is that true? 20 plus a negative 2 does equal 18. That's true. Now I'm going to try the second equation. 6x minus 2y equals 26. 6 times 4 minus 2 times negative 1 equals 26. 24 minus 2 times a negative 1, all right, so that's going to change this to a positive, equals 26. That is true. So I see that my solution, when solving simultaneous linear equations using the elimination method, my solution for these two linear equations is 4 comma negative 1. So now let's look at something a little trickier than the last one, because there, in our first example, we were able to just add things up and something would eliminate. In this case, such is not the case. We see that we can't add them up because nothing will cancel. So I guess I have to think about what I really need to do. I need to find a way to get either my x's to match up or my y's to match up. Well, 3x and 4x both have a lowest common multiple of 12. So what I'm going to do is multiply this entire equation by 4 and this entire equation by 3. What that's going to get me is 12x plus 20y equals 4 and 12x plus 21y equals 6. Now, what I'm going to have to do, instead of adding them together, I'm going to subtract the values. So I'm going to subtract this entire equation from the second. Using elimination, here's where it gets tricky. You can add or subtract depending on your situation. I could have also multiplied this by a negative 3 and then added, but I'll just go ahead and subtract. So I have 12x minus 12x leaves me with a 0x. 20y minus 21y leaves me a negative 1y, or just a negative y. And 4 minus 6 leaves me with a negative 2. So if I divide both sides by negative 1 to get y by itself, I get y equals 2. Now that I get y equals 2, I still have to solve for x. Now, conveniently, I can go ahead and take this y and plug it back into one of the original equations. I don't have to use the ones that I've expanded over here since they're the same values. So I'm going to go ahead and go with the first equation, 3x plus 5 times 2 equals 1. 3x plus 10 equals 1. Subtract 10 from both sides. 3x equals negative 9. So x equals negative 3. So far I think my solution is going to be negative 3, comma 2. What do I need to do? Right, I need to go ahead and test. So I'm going to go back to the original equations. And really, I don't need to test the first one, since that's what I used to get my answers, but I'm going to go ahead and go do it anyway, just in case I made a mistake somewhere. 3 times negative 3 plus 5 times 2 equals 1. Is that true? Negative 9 plus 10 equals 1. That's true. Now I have 4 times negative 3. 4 times negative 3 plus 7 times 2 equals 2. Is that true? Negative 12 plus 14 equals 2. That is also true. I know my answer is correct. So here's where I have a challenge for you. I want you to solve the simultaneous equations x over 3 minus y over 2 equals 1 and x minus 4 over minus y over 5 equals 1 over 6. Here's a hint. What I would recommend is changing these equations so that you are no longer dealing with fractions. If not, you'll probably end up feeling like the guy on the right.
Looks like he took a right turn and should have gone straight.